Hi guys, today we're going to talk about Gaussian elimination, and Gaussian elimination is just a way to use matrices to solve systems of equations. And I know we haven't had any background, at least in this class, on matrices, but that won't stop us from doing this, okay? So that's where we're headed. This is the last topic for the college class. High school kids, or those taking it for high school credit who are juniors, we still will do a little bit more in the next week, but this is our last main topic. So Gaussian elimination, first of all, has to start with augmented matrix. Okay, and so let's talk about what a matrix is first. A matrix is just a list of elements or numbers, and we do use the brackets to signify a matrix, and they're usually named by a capital letter like A or B. Okay, an augmented matrix is a separated matrix, and we have coefficients on the left and we have constants on the right from an equation. So augmented matrices represent systems of equations. Okay, so this first example is a system of two equations. We have 2x plus 5y equals -1 and 3x minus 2y equals 8. And so if you see, my 2 and my 5 come from the x and the y. My -1 comes from the constant on the right. Okay, and then this bottom row comes from 3, -2. Okay, so 3, -2, and then we have 8. So again, your coefficients are on the left and your constants are on the right. And this is called an augmented matrix. Now, let's see what this one would look like. So this would be a good time to pause after I write out the three equations and see if you can write the augmented matrix, because this will be the first step in solving equations using Gaussian elimination. So take a minute and see if you can write the augmented matrix for this system. Okay. So I write the coefficients on the left. So I get 1, 2, -2, and 5, 9, -4, 3, 4, -5. And I have my separating line. I get -2, -3, -3. Okay, so that's my augmented matrix. Okay. Now, what we want to do when we use Gaussian elimination is we want to get our matrix in the form that's called row echelon form. Okay, and so that's a weird word, but row echelon form, this is REF. Okay, and we also have a reduced row echelon form, or REF, and it's really nice to use with Gaussian elimination, but it requires quite a bit more work, and so we're just going to deal with the REF part. Okay, so row echelon form of a matrix, okay, we'll have ones in the main diagonal. Okay. So this is a matrix that has 3 rows and 3 columns. This is just a regular matrix, right? It doesn't have the separated form right now. So it would have ones in the main diagonal, and then we have zeros to the left or to the bottom underneath those ones. Okay, so then we have zeros beneath the ones. And then everything else doesn't matter. You can have number, number, number. Okay. Now, if we have reduced row echelon form, these are also all zeros, and so we just have 1, 1, 1. But row echelon form has ones in the main diagonal, and it has zeros everywhere else. Okay, so that's a very important part of our Gaussian elimination, is we're going to try to get this row echelon form. Okay. Now what's nice about this row echelon form is that if we have a 1 here, we're going to know exactly what z is. And if we have a 1 here, and if we already know the z, we'll be able to figure out what y is. And then we can go back substituting for x as well. So it's the same thing we were doing. It's just in a matrix form. And we don't have to worry about our coefficients or our letters this way. Okay. Now, how do we get to that row echelon form? We use what are called elementary row operations. And there are three. Okay. And elementary, again, just means beginning or basic. Okay, so there are three things that we can do to a row in a matrix. And so rows go across. Okay. And the first thing that we can always do is we can switch or interchange two rows. And the way we symbolize that or show our work, if we want to switch row 1 with row 2, so we just use little subscripts, we use a double-headed arrow. Okay, so row 1 and row 2 are going to switch. Okay, the second thing we can do is multiply a row by a non-zero number. Technically, you can divide as well. Like if you want to divide by 5, you could do that, but we technically say that's multiplying by a fifth, right? So we just say we can multiply by a number. So if you want to do that, you're going to say number, whatever that number is, row 1, and then it's going to go back in row 1's place. Okay, so we this says I multiply row 1 by a number, and I'm going to put it back in row 1's place. I took its spot. Okay, and then you can replace a row by the sum of any two rows or multiples of rows. And so this would be like row 1 plus row 2, and that's going to replace maybe row 2. Okay. We can also have numbers in front of here. So those are the three things we can do to a row. So we're going to practice just those row operations for a few minutes before we get into the actual Gaussian elimination. So let's say we have the matrix 3, 2, 5, 6. Okay, so that's our basic matrix. 3, 5 is row 1, 2, 6 is row 2. Okay, so let's say I want to take twice row 1, and I'm going to put it back in row 1. Okay, what would that look like? Okay. Well, first thing I like to do is go write down anything that won't change. Okay, so does row 2 get bothered? No, so let's go ahead and rewrite it. Okay, now what's this tell us to do to row 1? It tells us to multiply everything by 2. So 3 becomes 6 and 5 becomes 10. Okay, so that was a row, an elementary row operation. We multiplied 2 times row 1. Okay, let's take this one again. Let's say we just want to switch row 1 with row 2. Okay. So we're changing both of these this time. So row 1 is going to go to row 2, and row 2 is going to go up to row 1. And so that would be a switching. And then let's say that we want to take 2 times row 1 minus 3 times row 2, and we want to replace row 2. So that's what that would look like. So which row are we not replacing? We're not replacing row 1, so let's go ahead and write row 1 up there. Okay. Yes, we're modifying row 1, but not in our final thing. We're just going to use it in between. Okay. So this says to take 2 times row 1, so I just put my numbers on top. So 3 becomes 6 and 5 becomes 10. And then I multiply by negative 3, or I multiply by 3 and then I subtract, however you want to do that. Okay, I just usually do a negative. So negative 3, this becomes negative 6, and this becomes negative 18. And then I put these together. So 6 minus 6 is 0, and 10 minus 18 is negative 8. So that is my resulting matrix. Okay, so those are row operations. Okay. So we're going to be using those to help us out with Gaussian elimination. Okay. So we're going to use these operations to get ones and zeros as needed. Now, quick little note, if I want to get 0, okay, you're going to add, okay, to get opposites. Well, we have to add and multiply, right? So we want to get opposites. So if you want zeros, we're going to get opposites. So we're going to have to multiply and add together. So maybe one way to think about that is, right, in 0 and a O. So if we want zeros somewhere, we're going to have to get opposites. And if we want ones, we do that by division, which is multiplication. Okay. So we're going to start off and just do a few examples. If you need a break, this would be a good time. Okay. This will be fairly long, and I apologize for that, but go ahead and make yourself stop every 15 minutes or so and take a break. Okay, so this system we could easily solve with elimination, probably. Substitution would be okay, but we know how to solve this just fine. But we're going to do this problem using Gaussian elimination just so you can see the beginning process of it. I am definitely not saying it's any quicker, okay, but it is another method. So first step, we write it as an augmented matrix. Okay, so 2, 5, -1, 3, -2, 8. Okay, so we wrote it as an augmented matrix. Okay, now our whole goal, keep in mind, is we want ones in the main diagonal, and then everything under that's a 0. Okay, so we want ones in the main diagonal. That's our goal. We want a 0 down here, and then we want numbers here. Okay, so we need this to look like that. Okay, so where do we start? Is there a best place? And the answer is yes. Okay, first thing we want to do here is get 0. We're going to go for this first. Okay, so to get 0, we want opposites. Okay, so 2 and 3, what would their number be that they have that we could multiply it by to get there? Okay, well, 6, right? If we want a 6 and a -6. So if I want a +6 on top, I'm going to have to multiply by 3. So 3R1. Okay. And then I'm going to multiply the bottom by -2. And I'm going to put those together. And I'm going to replace row 2 because that's where I want that 0 at. Okay, so we want opposites here. That's our first step. Okay, so opposites to get 0 right there. Okay, so if I multiply this top one by 3, I get 6, 15, and -3. Down here, if I multiply by -2, I get -6, +4, and -16. Okay, so now I put these together. We did not change row 1, so let's go ahead and write row 1 down. Because again, this just tells us we're replacing row 2. We used row 1, but we didn't change it. Okay. Now, this says row 2 comes from the multiplication and then the summing. So 6 and a -6 make 0. That's what we were looking for. 15 and 4 make 19. And then we have a -6 and a -16, which makes -19. Okay, so I am on my way. Okay, because I have my 0, so that's good. Now we want to continue on this and get a 1 here. Okay, so our next step is to get 1. And how do we get 1s? We get 1s by dividing or multiplying by the reciprocal. Okay, so we're going to take 1/19 and multiply it by row 2. Or we're taking row 2 and dividing it by 19. Okay, and we're replacing row 2. Now we might be worried that that messes up that 0 we already did. The zeros don't get affected by multiplying, so we're good to go. Okay. So did we change row 1 any? No, so this needs to be 2, 5, -1. Okay. And then 0 divided by 19 is 0. 19 divided by 19 is 1, which is what we really wanted. And -19 divided by 19 is -1. Okay. So far we have our 0 and our 1. And all we're missing is making this a 1. Okay. And how do we make it a 1? We do that by dividing. And so how do we get 1? We divide by 2, or that's the same thing as multiplying by a half. So we take it 1/2 of row 1, and we replace row 1. So row 2 does not change. We have it where we want it. So 0, 1, -1. Okay, so half of 2 is 1. We get 5/2. And then -1 divided by 2, or times a half, is -1/2. Okay, so notice we have the 3 numbers that we wanted, right? The 0s and the 1s in the place that we were going for. Okay, so now, and I told you this would be long, right? Now we write it as an equation again. So we get x plus 5/2 y equals -1/2. And then we get y equals -1. So what good has that done us? Well, it tells us what y is. Okay, so now we're going to take y and substitute back in. Okay, so now that we know what y is, we can put it up here for y. So we have x plus 5/2 times -1 equals -1/2. Okay. So this is -5/2, so I actually add 5/2 to -1/2. I get 4/2, which is 2. So my answer is 2, -1. Okay, so that is Gaussian elimination. Does it take a lot for a system of 2? Yes. Okay, but think about it. If we could do this much work for 3 or 4 variables, then it's not that bad. Okay. Calculator-wise, like I said, you can do it in a few button strokes and you're done. Okay, but can't really teach you that yet. So let's try another one. On your final, if there is one, they will tell you to do it a specific way. Okay. And if you do it or do not do it by Gaussian, if they tell you to, I can give you some points, but you can't get full credit, right? You need to be able to do it the way they ask you to. So I would strongly suggest at least being able to write it as a matrix. Okay. And then try to get the 1s in the main diagonal and 0s on the bottom. Okay. So first step is to write it as that augmented matrix. Okay. And again, our goal is 1, number, 0, 1, and a number. Okay. We have to get that 1, 0, and 1 working for us. Okay. So again, we want to get this one taken care of first. And so we want it to be a 0, and we get zeros by doing opposites. Okay, so what do 4 and 3, what number could they make? They could make a 12. So we need a 12 and a -12. So I'm going to multiply my top one by 3. Okay, so 3 times row 1. And then I'm going to multiply this one by -4. Okay. So row 2 by -4. And that's going to equal, not equal, sorry. We're going to replace row 2 with that. Okay, so 1 does not change. Okay, so 3 times row 1, I'm going to go put my numbers up top here. And then -4 on the bottom. Okay, so 12 and -12 make 0. Just a second. He's already had one. So 12 and -12 is 0. -15 and 16 is 1. And then 36 minus 40 is a -4. Okay. Now, what happened here that's pleasant or nice for us? A bonus. Okay. It already gave us a 1, even though that's not what we were looking for at that point. Okay, so sometimes one step will give us 2 steps. Now, the last thing we have to do is get that 4 to be a 1. And when we want 1, we do division. Okay, so how do we get a 1 here by division? We need to multiply by 1/4. So we take 1/4 of row 1 and make it into row 1. Row 2 does not change. Okay, so 4 divided by 4, or 4 times a fourth is 1. -5 times a fourth is -5/4. And then 12 times a fourth is 3. Okay, so we've gotten the 3 pieces that we need for that row echelon form, right? The 1, 0, 1. So now we write this system of equations again. We have x minus 5/4 y equals 3. And then we found out that y is equal to -4. Okay, so that was the important piece that we need. So now we can go plug in for the y. So x minus 5/4 times -4 equals 3. Or x plus 4 equals 3. So x must be -1. Did I mess up there? Nope. Okay, so 5/4 times 4 is 5. And if we subtract 5, we get -2. So our answer is -2, -4. Okay, so that's how you do it with 2. And again, that would not ever be your fastest way to do it, but it is a method that works. Okay, so now we want to look at it with 3 variables. Okay. So again, this might be a good place to take a quick break and then come back. Okay. So this takes me a minute to write it down. If you are missing a variable, you would just put a 0 in its spot. Okay. So here we have 3 variables, 3 equations. We just set up our matrix. So I have 3, 7, -7, 1, 2, -3, 5, 6, 1. And then the coefficients are constant, are -4, 0, -8. Okay, so what does our row echelon form matrix look like for a 3x3? Okay. Well, we're going to want 1s in the main diagonals, 0s below that, and then we can have numbers in these spaces. Okay, so I'll let you see that a little bit closer. So we want 1s in the main diagonal. We have to have a 0 in that second row and 2 zeros in that third row. Okay, so that's what row echelon form would look like. So that's our goal. So where do we start here? Well, bottom left-hand corner is a great place to start. Actually, before I do that, I see something that'd be really nice. Do you see how that 1 is already in the beginning position? Well, we want a 1 up in that top left position, so let's flip-flop. So let's take row 1 and flip-flop it with row 2. Anytime you can have a 1 in that top left, we want to do that. Okay, so Let's flip-flop there. So we get 1, 2, negative 3. And then we get 3, 7. Oops, I wrote that wrong. Make sure you take everything with it. So 3, 7, negative 4, 5, 6, 1, negative 8. Okay. So there we flip-flopped. We want that 1 up here. So we're actually glad to have that, and we do not want to change it. Okay. Now we're going to use that to get zeros here. We're going to actually do that at the same time. Okay. So we want zeros. Okay, so the first thing, let's look at just the first two. So 1 and 3, what would a number be that those both go into? And it's 3. So we want a 3 and a negative 3. So if I multiply this top row by negative 3, and if I add it to row 2, and then replace row 2, that's what I want to have, okay? I don't want this first row to go away yet, right? Because that 1 needs to stay there. So let's go ahead and write row 1 down. Okay, so we took negative 3 times row 1. So this is negative 3, negative 6, 9, and 0. And I say I want to add it to row 2. Okay, so negative 3 plus 3 is 0. That's what we want. Negative 6 plus 7 is 1. And then 9 minus 7 is 2. And 0 minus 4 is negative 4. Okay. Next, let's do that same thing with the third row. So we need opposites, and we want to use that first row again, so 1 and 5. So this time we want to multiply by a negative 5 up here. So that's negative 5, negative 10, positive 15, and 0. So I'm doing negative 5 times row 1 plus row 3, and I will be replacing row 3. If you think back about how we did the 3 variables anyways, this is what we did. We just don't have all the letters to deal with in this case. Okay. So 5 minus 5 is 0, and 6 minus 10 is negative 4, and 1 plus 15 is 16, and negative 8 plus 0 is negative 8. Okay. So what have we accomplished here? Well, now we have the 2 zeros in that first column that we need. Okay. So now let's move in this way. What do we need this to be? Okay. We need a 0 as well. Now, we do not want to use that top row anymore, because anything I do and add together, I'm now going to have something that messes this up. So I only want to use the bottom 2 rows now. Okay. So we need opposites. So I have a negative 4 and a 1. And again, that first one, let's not change any. Okay. So we want to take 4 times row 2 and add it to row 3, and then replace row 3, because we want opposites here. Okay, so 4 times row 2. So that gives me 4 and 8 and what, negative 16? Okay, so if I put those together, and I do not want to mess up row 2. Okay, so I keep forgetting to do that. So now let's put 4 minus 4 is 0, and then 8 and 16 make 24, okay. And then negative 16 and negative 8 make negative 24. Okay. So right now I have 2 1s here. I have 2 zeros. Okay. Oops. So the last thing I need to do for my matrix, at least, is to get this to be a 1. And so we divide by 24 or multiply by 1/24. So a 1/24 of row 3, and I replace row 3. Okay, so 1, 2, negative 3, 0. 0, 1, 2, negative 4, and then 0, 0, 1, negative 1. So this is my my reduced echelon form, because I have the 1s in the main diagonal and the 0s down here. And so now I can write this as x plus 2y minus 3z equals 0, and y plus 2z equals negative 4, and then I know that z is negative 1. So now all I have to do is back substitute. Okay, so we have y plus 2 times negative 1 equals negative 4. Or let's see, this is negative 2, so add that and we get a negative 2 for y. Okay, and then we can go up to the top and plug it into that first one, which is x plus 3 times negative 2 minus 3 times negative 1 has to equal 0. And we should be able to find out what x is. So we get x minus 6 plus 3 equals 0, or x equals 3. And I think I messed up somewhere, so let's just see a minute. So x, this is negative 3. Oh, oops, sorry. This should have been a 2. Apologize about that. So x minus 4 plus 3 is x minus 1, and so we add the 1 to the other side and we get a 1. So our answer is 1, negative 2, negative 1. Okay. So that is how we get 1s and 0s. So you get 0s by doing opposites, and you get 1s by dividing or multiplying by its reciprocal. Okay. So let's look at a couple more. And then tomorrow I'll have another example or two for you, and then you'll need to practice, okay, at least by yourself. So let's take x minus 3y plus 4z equals 1, 2x minus 5y plus 3z equals 6, and x minus 2y minus z equals 5. So first thing is to get that augmented matrix. We just do that with our coefficients. Okay. And again, we want 1s in the main diagonal, 0s underneath. Okay. So should I flip-flop here? And that's totally up to you. We already have a 1 in that top left, and so that's really nice. So I would just leave it. Okay. We do want to get 0s here. That's the next step. Okay. So we use the first one to do that. We do not change the first one. So the first and second one together, we need a 2 and a negative 2. So I'm going to multiply negative 2 times the first row, add it to row 2, and then it's going to go back to row 2. Okay, so again, row 1 should not be changed. You're just putting in for 2 and 3. Okay. So if I multiply row 1 by negative 2, and then I add them together, negative 2 and 2 make 0. That's what we wanted. 6 and negative 5 make 1. Negative 8 and 3 make negative 5. Okay. And then 1 and, whoops, I forgot to multiply that one. Negative 2 and 6 make 4. Okay. Now we want opposites for the bottom as well. Since these are both 1s, all we have to do is multiply the top by a negative, or the bottom by a negative, it doesn't matter. Okay. But then we just add it to row 3 and put it here. So if I take my top by the opposites, I have negative 1, positive 3, negative 4, negative 1. And again, I just write mine either above or below, whatever I have room for. So this becomes 0, this becomes 1, this becomes negative 5, and this becomes 4. Okay. So some good things happening here. More than we expected, maybe. Okay. And you may notice something kind of strange here anyways. But, so now next step, whoops, that one shouldn't have been, right? Oops. This needs to be 0. And so we do that by getting opposites. So we take opposite of row 2, add it to row 3, and we replace row 3. Okay, so all we do is take the opposite of the second row. And so when I do that, 0 and 0 still make 0. Negative 1 and 1 make 0. Positive 5 and negative 5 make 0. And a negative 4 and a positive 4 make 0. Okay, so we end up with this situation here. Okay. Anytime I end up with all zeros on the left, we have a unique situation. Okay. This is infinitely many solutions because this is still a true statement, right? 0 is equal to 0. Okay. So this is where we have to let, in this case, we're going to let z equal z. Okay. So a lot of you, when you're solving some of these, you went ahead and said that there's infinitely many solutions, but you didn't describe those solutions, and you need to still do that. Okay. So if I look at this and write this, this is x minus 3y plus 4z equals 1, and I have y minus 5z equals 4. Okay. And we're going to let z equal z. So we're going to plug in for z, and we're going to get each letter by itself. Okay. So in this case, we know that y is equal to 5z plus 4. Okay, because we just got the y by itself. Then we go up to the top and we plug in. Okay, so what is y? Y is 5z plus 4. And then what is z? Well, z is just z. And then we need to simplify what this looks like. Okay, so we're getting these all in terms of z. And it's just easier to do z instead of x or y since you already had a blank for z. So we get x minus 15z plus 12 plus 4z equals 1. Okay. And so here we get x by itself. And so if I move, this is negative 11z, so if I move it to the other side, I get 11z. And then here, move the 12 over. Well, just a second, that's a negative 11z. And that should be a negative 12. Okay, so we add 12, we get 13. So there's my x. So your answer is 11z plus 13, 5z plus 4, and then z. And again, what information this gives you is you can generate a triplet. So if I told you z was 0, then we know y is 4, and we know x is 13. So one ordered triplet is 13, 4, 0. But it's not the only one, because then I could go in and plug 1 in for z. And so if I plug in 1 for z here, another ordered triplet that works is 24, 9, 1. And so this is a system that just lets you generate all of your answers. Okay. Now, one final one for today. And again, I'll do a couple more examples tomorrow, maybe, if you think you need it. Okay. I have x minus 3y plus z equals 5. And actually, maybe I should do one more for you right now. Okay. And those should not have been there to start with. I apologize. Okay, so we take these equations and we write them in a matrix. So 1, negative 3, 1, 5, 3, negative 7, 2, 12, and 2, negative 4, 1, 3. Okay. Now, are we happy with our top equation? And the answer is yes, because we have a 1 here. Okay, so we do want to start here and get zeros. We do that by opposites. Okay, so we will not change our first one. Okay, So what we need to do is multiply our top by -3. So -3 times row 1 plus row 2 is going to give us row 2. Okay. So -3 plus 3 is 0. 9 minus 7 is 2. Let's see. -3 plus 2 is -1. And -15 plus 12 is -3. Okay. Now we need opposites here with 1 and 2. So let's take -2 times row 1 and add it to row 3, because that's how we get opposites. Okay. So -2 plus 2 is 0. And this is 6 minus 4 is 2. And -2 plus 1 is -1. And -2 times 5 is 10. -10 plus 3 is -7. Okay. So here we have our 1, 0, 0. Okay. So now we head in to the right, and we need to deal with this by getting opposites as well, because we want 0, and we use the 1 up above it. So let's just take, you can do the opposite of either, but -R2 plus R3, and we want to replace R3. Okay. So row 1 and row 2 don't change. Okay, so opposite of here, so that makes 0, and opposite here makes 0, and opposite here makes -4. Well, we have the issue again. We have all zeros here. But if we look at that, we're seeing that 0 equals -4. Is that a true statement? No. So this is a no solution. Okay. So if we have all zeros on the bottom with a number over here that's not 0, that's a no solution. But if you have zeros all the way across, that's when you get infinitely many answers. Okay. So let's do one more 3 by 3 that we have to do everything with. Okay. And then we'll call it good. Maybe you want to try this one without looking, and then go back and check with me. Okay. So let's try this one. I'm just going to go ahead and give you the starting matrix this time. Okay. So this would have come from from 2x minus 3y plus 2z equals 13, and 3x minus 4y minus 3z equals 1, and 3x plus 1y minus z is equal to 2. Okay. Now, do we want to do any switching? It's kind of up to you. I'm not going to. What I'm going to deal with first is making these 0. Okay. So we can do that by using opposites. So this time I'm going to take -3 times row 1 and add it to row 2 and replace row 2. Again, row 1 does not change. Could you divide by by 2 to get a 1 there? You could, but you're also dealing with fractions, and I really didn't want to do that. So, okay. So, and then we're going, oops, that has to be 2 times row 2. Okay, so this is -6 and +9 and -6 and -39 because I multiplied by a -3. And then here I want to multiply by 2, so that's a 6, a -8, a -6, and a 2. So if I put those together, I get 0, 1, -12, -37. I'm going to do the same thing with the bottom, and I can take -3 times row 1 plus 2 of row 3. And that's this -6. Let's see. So this would be, if we did times 2, this would be 6, 2, -2, and 4. And then my top one was -6, 9, negative 6, negative 39. Okay. So I get 0, 11, negative 8, and negative 35. Okay, so the good part here is I do have my 2 zeros. Okay. Now I want to focus on making that a 0. And so we're going to use our second row to let us do that. So our first row won't change and our second row won't change. So we want to get opposites here because we want a 0. So this is 11 and that's 1. And actually we're happy with that 1 because it's in that main diagonal. Okay. So we multiply by negative 11. So negative 11 times row 2 plus row 3 is going to replace row 3. Okay. So if I take row 2 by negative 11, I get 0, negative 11. What is that, 132, I think? So we have positive 132, and then negative 37 times negative 11 gives us 407. Okay, so if I add those together, I get 0, and I get 0. And then negative 8 plus 132 is 124. And 407 minus 35 is 372. Okay, so hopefully this is good. Okay, so we have the zeros here and we have a 1 here. Our next goal is to get a 1 here. Okay, so how do we get 1s? We get 1s by dividing. So we need to take this row and divide it by 124 or 1/24 times row 3, and we're going to replace row 3. We do not want to replace row 1 or row 2, so go ahead and write those down. Okay, so 124 divided by 124 is 1. That's what we were looking for. And then 372 divided by 124 is 3, I believe. Okay. So right now, we are here. And our last step, if you want to in row echelon form, is just to get that 2 and make it a 1. Okay? And so how do we get 1s? We just divide or multiply, in this case by a half. So a half of row 1, and I'm going to replace row 1. And I didn't replace row 1, I apologize. Okay, so row 2 and row 3 are going to stay the same. So half of row 1 is 1. This is negative 3 halves, and this is 1. This is 13 halves. Okay, so here we're in row echelon form. We are ready to find out what our letters are. Okay, so we have x minus 3 halves y plus z equals 13 halves. And we have y minus 12 equals negative 37. Then we have z equals 3. Whoops, and that should be 12z. Okay. So we know what z is. We're going to go plug it in up here. Okay. So y minus 12 times 3 equals negative 37. So y minus 36, we're going to add 36. So over here we get a negative 1. And then we go up to our top here. So we get x minus 3 halves times negative 1 plus 3 is equal to 13 halves. Okay, or we get, what is that? This is 3 halves plus 3. So is that 9 halves, I think. So if we subtract 9 halves from both sides, we get 4 halves, which is just 2. So our answer is 2, negative 1, 3. And how can we check this? We can plug it back in. Okay. So yes, I know this is kind of painful. Putting it in a calculator is great, but again, we don't all have that, and I don't think they let you use that on your final. So here's how you do it by hand. If you'd rather do it without matrices, then you could get some credit, but you're not going to get your full credit. So make sure you know what row echelon form is, okay, or reduced echelon form is. So tomorrow maybe I'll do another example of a 2x2 and a 3x3 and then have you practice. Okay, so please let me know if you have any questions and have a good day.